Right, our next section is writing linear functions using technology. So we are going to use the calculator to write an equation for this situation. The table below shows the number of tickets sold at various ticket prices for an outdoor concert. There you go. Use your calculator to determine the equation of the line of best fit for the data represented in the graph. We're going to use stat, edit, and linear regression. Now, I put it on here, but also on your formula chart, it explains linear regression. First, you're going to enter your data into the table using stat, edit. So, let me clear my calculator out, press stat, edit. Top numbers are x's, so 21, 30, 35, 42, 46. Bottom numbers are y's, 130, 118, 99, 84, 65, 58. Okay, the second step to linear regression was to calculate the slope and y-intercept using stat, calc, linear regression. So press stat, calc, linear regression is 4. I go down to enter, and it tells us, dimension mismatch. Let's see what happened. Let me look at my stat. Oh, I see the problem. So see what happened here is we have one more number on our right side than on our left. So let's see what I missed. So 21, 30, 35, oh, I forgot my 38. And then 42, then 46. So let's go back and do it again. Stat, calc, lin reg, enter, 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 and we get a, which is the same thing as slope, negative 2.72, and a b of 183.8. Let's call it that. So my equation would be y equals negative 2.72 x plus 183.8. There you go. Number 8 says, what is the solution to the following equation? Now I have a note over here that you can solve the problem algebraically or use the intersection method on your calculator. Now, I'm going to solve it algebraically, but then I will show you how to find the same answer using the intersection method. So the first thing we want to do here, if we're doing it algebraically, is to distribute and get rid of all of these parentheses. 6 times 5n, 30m, 6 times negative 3 is negative 18. 1/3 times 24m, well, 1/3 of 24 is 8m, 1/3 of 12 is 4. Then we're going to go the baby to the mama route, look at the m's. This is the baby m, so we're going to subtract 8m from both sides, which gives me 22m minus 18 equals 4. Since this is the side of m, we're going to move the numbers to the other side by adding 18 to both sides, which gives me 22m equals 22. This is going to be easy. We're going to go ahead and get rid of this 22 by dividing both sides by 22. And that would give me m equals 1. Okay, so that's the algebraic method. Now to do it using the calculator, you are going to plug it in one equation, or the left side will be y1, the right side will be y2. So I'm going to push this in, and I'm going to change my m's to x's. The second line I'm going to put the other one. I'm going to look at the graph, and it will show me two lines. There's a line for y1, there's a line for y2. We want to see where they cross. Can you see where they cross? Well, kind of, probably. Okay, so what we're going to do once we can see where they cross is we're going to use the intersect tool, which is second trace. I'm going to go down to intersect. We're going to press enter 3 times. 1, 2, 3. And the x value is the one we are looking for. So x equals 1, which is what we found. So that's how you use the intersection tool on the calculator to find the answer to a question like this, where there's only one variable. Next problem says the following table shows the amount of money Jackie earns for working X hours at her part-time job. And we've got hours and earnings. Which equation represents the total money Jackie makes? Well, there's really, the easiest way I can think of to do this is to plug each of these into y equals and then check the table to see if these numbers match. And all 4 of them would need to match. So the problem with that is that this first one is set equal to x, but we need it to be set equal to y, so I'm going to divide by 7 on both sides. which gives me y equals x over 7, which is the first equation I'm going to test. So I'm going to plug in, get rid of these guys here, plug in y equals x divided by 7. Okay, I'm going to go to my table and check the earnings. So $70 at 10 hours. Let's go down to 10 hours. 10 over 7. That is not correct. So that's out. Let's go to the second equation. Y equals 7x. Okay, let's go to our table. At 10, 70. Good. At 15, 105. Good. At 20, 140. It's good. And at 25, 175. That's our correct answer. That's all it takes. If you have an equation or if your answer choices include y equals, chances are you can do a much faster work if you use the calculator. Moving on to the final page of day 1. Star means we're going to be able to use our calculator, use our formula chart possibly. Asks us to find the equations of the following graphs. Now for each of these we need the rise over run, and we also need the y-intercept. So the rise over run, we're going to again find two pretty points. Here's one, here's one. We are going to connect them. This is down 2. This is right 4. My slope is negative 2 over 4, which reduces to negative 1 over 2. My y-intercept was one of the pretty points I chose. It is at 1. So my equation would be negative 1/2 x plus 1. If you need to check, you can always plug it into your calculator and make sure that it matches. Looks pretty good to me. Okay, moving on to the next one. Here we don't have a straight line, but it gives us pretty points, which makes it a little bit easier. So I'm going to go ahead and use these two pretty points. Okay, this one goes up 4 and right 1. So this would be slope of 4 over 1, which reduces to just 4. My y-intercept, right there at the origin, which is 0. Now, because the y-intercept is 0, it's not necessary to put it into the equation. You can just put 4x. Although, if you must, there is an invisible 0 at the end there, but that will not be part of an answer choice on a question in the final exam. Number 11 says, the Weiler Aerial Tramway in Franklin Mountain State Park begins at the tramway station, which is at an elevation of 4,692 feet. It takes 4 minutes to reach Ranger Peak, which is at an elevation of 5,632 feet. Which equation is used to estimate the height of the tramway t seconds after it left the station? So, a couple of things going on here. First of all, we need to point out that we are going up, okay? Starting at 4692, that is my beginning point, which is B. Takes 4 minutes to reach Ranger Peak, which is at an elevation of 5632, which means it's going up however many feet that is. Now, here's the tricky part. It says it takes 4 minutes to reach Ranger Park. But the question is in t seconds. So we need to figure out how many minutes are in how many seconds are in 4 minutes. Well, if there are 60 seconds in a minute, that would be 240 seconds. So one thing that we can do that might work for us well here is to plug these numbers into the equation. This would be my time. Time is 240 seconds. And see which one equals 5,632. This is the way I would solve this problem. So I'm going to go back to my table, or go back to my regular calculator, and plug in each of these equations. I'm going to use 240 for t. So 4692 minus 3.9 times 240, 3,756. So that is incorrect. We need it to be 5,632. So I'm going to do it again. I'm going to copy this down, move it here a bit. I'm going to change that minus to a plus because that's the only thing that changes here. And I'm going to press enter. 5628. That's not quite right either, although it's pretty darn close. It's only a few seconds off. So I'm going to keep that one as a star because that might be one of those goofball things. Okay. We're going to plug in the next one, which is 5623 minus 3.9 times 240, 4687. Again, real close, but not quite right. And the last one, 5623 minus 4692 times 240. That is not even near close. So here's the issue. This is a bad question. It's not anyone's fault except mine for not checking it. So what we're talking about is what is happening to the train after it leaves the tramway station. Well, it's going from 4,600 feet to 5,600 feet, which means that my slope needs to be positive. Okay? So this is the slope. One is a positive slope, one's a negative slope. The positive slope is going to win. Now, this was a few feet off. It was pretty darn close, and probably what happened was it just cut off the decimal a little bit too soon. But that's what we're looking for. Number 12 says, write an equation in slope-intercept form for the function represented in the table below. A couple of ways we could do this. We could use the linear regression that we did on the other side and plug all these numbers in the calculator, or we could use the table to find the change of y over the change of x, which is another method of finding slope. So from 1 to 2 is a change of +1. This is my change of x since it's on the side of x. Now, in order to make this work, I need to use the same two values directly across from each other. And from 3 to 1 is a change of -2. This is my change of y, because we're on the y side now. So this means my slope is going to be -2 over +1. -2 divided by 1 reduces to -2. Now the trickier part here is figuring out where my y-intercept is, what b is, but the y-intercept is always where x equals 0. So if you've got that, if you have a 0 on your table, then the y value is going to be your y. So my slope is going to be -2x plus 5. Okay. Last question. Writing and solving equations involving direct variation. We've got a star here, so we're going to look at our formula chart. It says the value of y varies directly with x, and y equals 6 when x equals 12. Find y when x equals 27. Well, here's my direct variation formula. It's y equals kx. Okay, so we're going to start there. Y equals k times x. I have an initial y and an initial x, which means that 6 equals k times 12. So the first thing I'm going to do here is I'm going to solve for k. To do that, I'm going to divide by 12 on both sides, and that's 0.5 if you want to use the decimal. 6 divided by 12, 0.5. So k equals 0.5. Now once I get that, I can plug in x to the equation. Y equals 0.5 times 27. Okay, that's k, that's x, so we're going to do that. 0.5 times 27 equals 13.5. Y equals 13.5. That's the end of day 1.